Your attack surface just got a lot bigger. How? Well, generative AI, this technology that is taking the world by storm and can do amazing stuff, also introduces some new threats with it and new risks. In fact, 4 out of 5 executives have said that they're not sure they can really trust generative AI because they have concerns specifically related to cybersecurity. They have concerns related to privacy and accuracy of what the system can do. If we don't address those issues, we don't have trust and we're not able to take full advantage of the technology. So what do we need to do in order to secure generative AI? Well, we need a framework that will allow us to take a look at these issues. So let's talk a little bit about what this is and how it works. Well, what starts is we have data. We use this data from a lot of different sources, and we use it to train and tune our models, which are the next component of this framework. We use the data to train the model, and then ultimately the model is used for inferencing. The inferencing is where we get our output. So this is how the thing generally works. In fact, we have to look at how we're going to secure each one of those. How do I secure the data? How do I secure the model? How do I secure the usage? And it turns out there's a couple of other things we need to take a look at that I'll show you before the video is over. Okay, let's take a look at securing the data itself. This is the data that we're going to use to train and tune the model. Therefore, a bad guy is going to look at that and see what they can do to it, because that's what they do. If it exists, they're going to try to mess it up. This is kind of why we can't have nice things, I'll tell you. And what they're going to do in this case, one possibility is poison the data. If they poison the data, then basically they introduce some inaccuracies or things like that that go then into the training and tuning of the model, and now the model produces bad results as a consequence of that. Another thing that could happen in this space is exfiltration. An exfil attack would be where someone breaks into this system and pulls data away from it. And this could maintain a large set of sensitive information, and another version of that is leakage. Leakage might be a more unintentional versus exfiltration is an intentional, where someone has come in. But the effect is the same. This sensitive data, and we may use a lot of really sensitive data to train our model and tune it, because that will make it more accurate and more useful in our use case. But as a result, now this ends up with a big bullseye on it that somebody is going to try to hit. Therefore, we're going to have to try to secure that. How could we do that? Some things that we should be taking note of is we should do data discovery and classification. I need to know where all the sensitive data is. Maybe these data sources were secured when they were in their various databases, but now that we brought all this together as a training system, maybe we didn't apply the same controls, and we need to. Classify that so that we know what level of security and protections are necessary. We want to also use cryptography so that we make sure that the data that does leak out or gets exfiltrated out is of no harm. No one can read it unless they're an authorized user. We also add things like access controls, which make sure that only authorized people can get into this system using strong multi-factor authentication and things like that. And then also we need to monitor the system. I want to know if this has occurred so that I can then take remedial actions and do the right sort of countermeasures and limit the exposure. Okay, now let's talk about securing the model itself. Now, how does this stuff work? It turns out very few people develop models for their organization because it's very computationally expensive, requires a lot of effort. So most people are leveraging existing models. In many cases, they get them from open source. And knowing where you're getting your model from makes all the difference in the world. So typically, I would import models from a lot of different trusted sources, but if I'm not careful, maybe I get a model that I think is trusted and it's not. Maybe it's a copy of a trusted one that has been modified in some way. And so that means I really have to consider basically the models as a supply chain. And I have to do supply chain management of the models themselves that go into whatever system I'm going to use. So in this case, I need to be able to make sure that I can trust what my sources are, and I need to be able to know that there are not bad things, not just bad information, actual malware. There have been researchers that have done a proof of concept to show that malware could be introduced through a machine learning model. So we have to be able to look for those kinds of things. Also, in many cases, we're going to use APIs as a way to communicate out to other services, maybe to communicate with a model if we're not hosting it directly ourselves. That API path could also be a path where an attacker could come in and introduce some sort of error that then affects our system. Other things, if we use plugins that elevate privilege, well, I need to be concerned about the privilege escalation that can occur and limit what it's able to do so that it's not able to also make changes here or put bad information out or even modify parts of my system. I want to make sure that I have a human in the loop to guard against some of those kinds of things. And then as well, I've been talking about IT attacks, but how about an IP attack, intellectual property? I need to be able to make sure that I'm not using copyrighted works in one of these sources, because then I could be sued for using information that's not really I'm permitted to be using. So what kinds of things should we be doing to guard against this? Well, I need to scan my systems just like I do for other types of malware and look for any type of harmful code that's being introduced into the system. I need to be able to harden my system. That basically means I'm going to remove any unnecessary services, change all the default user IDs and passwords, all of those kinds of things. The system should be able to withstand an attack, and I do that hardening by removing and limiting the attack surface as much as I can. Then I use things like roles-based access control. Again, trying to make sure that something like this can't do more than it's supposed to be able to do. And I can do that on a per user, per account basis. And then look at my sources, vet those sources, make sure that they are trustworthy, make sure that they don't contain copyrighted materials that will get me in trouble legally, and things of that. So while these are more IT, this is IP. Okay, now we're going to take a look at how do we secure the usage of our generative AI. We've looked at the data, the model, now how it's used. And it turns out one of the main ways that this system can be manipulated by a bad guy, a malicious actor, is through what's called prompt injection. And prompt injection is, in fact, the number one on a list of top 10 vulnerabilities mentioned by OWASP, if you're familiar with that organization. So prompt injection, in that case, we have a user that comes in and basically tries to jailbreak the large language model or generative model that's behind this by issuing commands, having the system do things that it was not intended to do, trying to get around the guardrails that are put there. It's almost a semantic attack. It's an attack with the words on the knowledge itself in many cases. So we basically, with that, can also sometimes bias the output, and therefore the information that comes out of the system is now not as trustworthy as it should be. Another type of attack someone may do is a denial of service. If I send enough attacks into the system that are complex, then maybe it starts bogging the system down because I can ask a question much faster than a system can answer it. So we send in a bunch of these and now the system becomes overwhelmed and it can't keep up anymore. And then the last one that I'll mention here is model theft. In this case, someone might not be able to just break in and steal your model if you've done a good job up here in the storing of your data and securing all of that. But what if they just put a number of different queries into the system and then take the output back and do that again and again and again? They can basically mine the model in order to get the information that they want. Then they could potentially go build their own version of this, and now they've essentially stolen your model in the process. So what can we do to guard against some of these threats? Well, one of the things we should do is monitor, in this case, monitor the inputs into the system and put guardrails around those. We'll never be able to put all the kinds of semantic guardrails that we need to make sure that someone can never get in, but we need to at least try and do the best job we can. There also will probably be a new class of tools that we're starting to see emerge. One example of this is machine learning detection and response. So we've done detection and response and security for a long time, but something that's specifically built for machine learning, maybe even generative models. This is going to be a new emerging area that we can start looking at. And then finally, some of our fundamentals using Security Information Event Management System, or a SOAR, a Security Orchestration, Automation and Response System. That is, monitor all of this so that I can see the abnormal inputs. I can see if the system is under duress, if it's being overloaded, and things like that. If someone's carrying data out, I could use some of those type of capabilities in order to be aware. So there you have a way that you can secure the usage as well. Okay, now for the big reveal of the two elements I told you I would talk about at the end. AI, generative AI, does not exist in a vacuum. It runs on IT systems. Therefore, we have an infrastructure underneath all of this, traditional computers. And the way we do security for those is something that I've talked about before. That's what supports all of these systems and makes it possible for them to do what they do. And what I've discussed before is this thing called the CIA triad: confidentiality, integrity, and availability. Those are the concerns that we have in securing an IT system. Those concerns don't go away just because now we move to an AI system. We have to do everything we've always done plus a little bit more. And that little bit more is all of these kinds of things that I've been talking about in the video. But we can't ignore the fundamentals of securing the infrastructure itself and doing the basic blocking and tackling that we always have to do on every IT system. And then finally, the last element here is one of governance. Not so much a security concern, but it's a big concern for the functional operation and correct results of the system. I need to be able to direct, manage, and monitor how the generative AI works. I need to ensure that it's fair, that it's not biased, that the model doesn't have drift over time because someone has introduced some incorrect information in it. I need to be able to ensure that that's not occurring. I need to be able to keep up with regulatory compliance and requirements issues, and ultimately make sure that the system operates ethically. So I need a governance layer here as well. Put all of these things together, and this is a security framework for generative AI. Now, if we think about, to summarize, what I've talked about in another video is using AI to create better security. And there's a lot of possibilities of what generative AI can do in order to make us better, make this a force multiplier for doing the best cybersecurity we've ever done. And then what has been the subject of this video is how we can use security to make sure that the AI is secure. So it's AI for security and security for AI. If we get all of that right, then we win. Thanks for watching. If you found this video interesting and would like to learn more about cybersecurity, please remember to hit like and subscribe to this channel.